do you realize that I am 10 to the 15th more accurate than you are? If we take an atom, a simple atom being a nucleus surrounded by an electron, turns out, this is obviously not drawn to scale, because the atom is 10 to the minus 8 centimeters in diameter. The nucleus 10 to the minus 13th, okay? That's a difference between the two is 10 to the minus 5, or 10 to the 5th, you're going to divide it. So if you take that volumetrically, 10 to the 5th, and cube it, you got 10 to the 15th. How big is 10 to the 15th? Well, that's not very distant from the number of seconds in the universe. If you take 16 billion years old and divide it into seconds, you have about 10 to the 16th, 10 to the 17th. Almost, this number almost reaches that kind. It's a very, very large number, which means simply this, that most of this podium is actually empty space. It feels solid because of an electrical simulation being occurred between atoms that sense each other's nearness. But it's mostly empty by a factor of 1 part in 10 to the 15th. So if I say there's nothing here, I'm 10 to the 15th more close to reality than you are if you say this is solid, because it's obviously not solid. There's no such thing as solid, it turns out. If we take a line and cut it in half, we can take what's left and cut it in half again. We can take what's left and cut it in half again and keep doing that. You would think that we could keep doing that, at least conceptually, forever. That no matter what we have left, we can cut it in half. It turns out that that's not true. It turns out that when we get to 10 to the minus 35 centimeters, if we try to cut that in half, whatever's there loses locality. It's suddenly everywhere at one instant. And an astonishing number of experiments back in 1982 confirmed this whole idea of what they call the Bell inequality. The net of it is that all photons in the universe know what all the other photons are doing. They're all interconnected in some strange way. And that's what leads, by David Bohm and others, to what they call the holographic model of the universe. But the very fact that subatomic particles have a property that's known as non-locality is astonishing. And this is true not just of length, it's true of mass, energy, and time. The Planck length here is 10 to the minus 33. The Planck time is 10 to the minus 43 seconds. There's no time smaller than 10 to the minus 43 seconds. The entire universe is made up of digits. It's a digital simulation. And so we have infinity at the macrocosm, it's finite. At the microcosm, it's finite. That's what leads to the field of, they call these indivisible units quanta, and the study of them is called quantum physics. And so we discover that you and I are in a physical universe that has boundaries. There's a finiteness of this, a very large, but still a finite size on the macro side, and it's also made up of indivisible units on the small side. It has a grain. It's digital, not analog, in effect. There's a movie that came out some time ago called The 13th Floor, which has nothing to do really with the major plot of the movie, but I think it's instructive to take a perspective of it. The movie in Los Angeles in 2005, a group of computer experts built a virtual simulation of a city and people, and they chose to create Los Angeles 1937 in this imaginary virtual environment, and all software. It was a virtual environment and populated with virtual people. And what made the thing kind of interesting is that they call the people in the software system a program unit, and people from the real world could enter that world for a brief period of time, for an hour or so, by exchanging their consciousness with the consciousness of the virtual people. This is obviously just a science fiction story, but very cleverly crafted. And so these people were able to go for a while in LA in 1937 and live for an hour or so in the bodies of the people, certain people there. And in the plot line of the story here, a murder mystery takes place. There is a major program manager that has been murdered, and it turns out the key to solving that murder is in the virtual environment. And that causes our hero in the story to have to go into there to try to solve, because they're going to pin this murder on him if he can't solve it, and that's what the plot line has to do with. And where the plot takes a huge twist is they discover there are other people entering LA 2005, and it turns out when the smoke finally clears, they're coming from LA 2025. And they discover then, as they realize all this, that even they themselves and the world they're in is a virtual environment. And there's, it's a very cleverly crafted science fiction story. But what makes the thing so provocative, just a piece of entertainment, don't misunderstand me, just a piece of entertainment. But it's conceptually provocative here because that's exactly the predicament we find ourselves in. That we are in an environment, while we may make virtual games and things and so forth, that in fact we ourselves are in a simulated environment that in which there's a reality beyond ours. And Scientific American in June of 2005 wrote an article about constants. We're going to get out here in a minute. But they concluded tentatively that our reality that we live in is but a shadow of a larger reality. That's their words, not mine. And so we find ourselves very analogous to that situation. We're here, man is here, and let's do a spread of size. On the large scale size, we have astronomy and astrophysics, the universe, but we discover it's finite. The macrocosm is finite. On the small side, we have indivisible units. That leads to quantum physics. Subatomic particles cease to have locality if they're divided. And that's at the microcosm. So we find ourselves, fascinatingly, inside a digital simulation. Everything we have is made up of indivisible units. It's like a piano rather than a violin. A violin is analog. A piano is digital. You have to hit one of the keys that are there. And that's exactly what they're discovering with the red shift. The red shift is digitized. That shakes everybody up. So the only place I've ever seen one, other than a mathematics textbook, is in a piece of art. A very interesting piece of art by Salvador Dali, Corpus Christi, where he renders the cross as a four-dimensional cube unraveled in 3 dimensions. It astonished me to realize that Salvador Dali had that sophistication in topology and mathematics to be able to even understand what he was saying there. Very effective use of it, as a matter of fact. But I want to show you another passage in the book, in the letter to Ephesians. In Ephesians chapter 3, Paul writes that Christ may dwell in your hearts by faith, that ye, being rooted and grounded in love, may be able to comprehend with all saints what is the breadth and length and depth and height, and to know the love of Christ which passes knowledge, that ye might be filled with the fullness of God. As you read that letter, you may miss something unless you look carefully. Have you noticed this? How many dimensions is Paul writing about? The breadth, the length, the depth, and height. 4 dimensions, one of which is a Greek term that can embrace time. Kind of interesting. 4 dimensions. The Bible's really said that all along. So we've been through randomness. We're now infinity. We've talked about the macrocosm, our universe that is finite in the macro sense. Let's take a look at the microcosm, at the smallness. We know the universe has a limit to how big it is. It may astonish you to realize there is a limit to smallness. And we call that quantum physics for some very interesting reasons. If I told you that this podium I'm speaking of is empty and not solid at all, and you took the view that no, it's obviously solid,